Hello there. Welcome back to Saxon 7.6. We're doing the second half of the book. Here we go. Starting off with lesson 61. And today we're going to add 3 or more fractions. And the way you do this, remember, if the denominators do not have the same number, you have to make them the same number. And we've done work on greatest common factors and least common multiples and things like that in the past. Let's do some steps here. If you need to write this down, go ahead and pause it, write it down, make sure you have it down. We can apply this to the fractions. Now, I want to make sure you still are working on knowing your times tables perfectly, very quickly. Your addition and subtraction tables perfectly, very quickly. The better you get this down, the faster all this algebra stuff will be. You might have heard horror stories of kids. Oh, yeah, algebra, oh, man, oh, geometry, oh, trigonometry, calculus, oh, rocket science, all that stuff gets easier when you know your tables, and you don't have to worry about them and mess around and waste time trying to remember what they are. And then you can focus on the new stuff instead of that. So that in mind, here's how you find a least common multiple. Remember, a least common multiple is the smallest number that other numbers will go into. Remember what multiples of 5 are, right? 5, 10, 15, 20. Multiples of 8 are 8, 16, 24, 32, 40, and so on. Now, the least common multiple of, let's say, 5 and 8, you could count and go, you could write across here all the multiples of 5. 5, 10, 15, 20, 21, 30, 35, 35, 40. Then you could go 8, multiples of 8. 8, 16, 24, 32, 40. You go, wait, 40. That's a common multiple. That's the smallest one, and there you go. That's your LCM. But you don't have to do that, because these get a little bit interesting as the year goes on. So you're going to want to have a method. This is the method. Number 1, use factor trees to find all prime factors of denominators. In other words, you take a denominator, you break it down into its prime factors, and there you go. Number 2, pick the largest number of each prime factor. In other words, when you use the factor trees, you'll circle your prime factors like 2 and 3 and 5 and 7 and 11 and things like that. All right. Then the last step is this: multiply the prime factors together. And I'll show you how this works. Let's do an example. There's your last step. Bake 10 to 15 minutes at 450 degrees, serve 6 to 8. That's optional. All right, let's add this together. Let's go back. I think all of us can see very easily that the common denominator of this 2, 4, and 8 all go into 8, right? That's the easiest thing. Now, some people have said, oh, well, you actually go ahead and take all the denominators and multiply them all together, then you'll get a common denominator. You will. You can multiply 2 by 4 to get 8, and then 8 times 8 to get 64. You could change these all to fractions that have a 64 in the denominator. That would work, but you'll be reducing the fraction a lot at the end. It's better to find the smaller one, the least common multiple, not just any common multiple. So let's go back, find all the prime factors. Let's go. Well, 2, well, that's nothing. It's just 2, right? It's already a prime number. 4, we can do this mentally. It's just going to be 2 times 2, right? 8, we know, is going to be 2 times 2 times 2. Now, if you wanted to draw the 8 and break it down to 4 and 2, that's fine. Now, you look and say, okay, well, pick the largest number of each prime factor. Well, there is only one prime factor, and that's a 2. Which one has the largest amount of 2's? It's this one right here, which means you multiply those together, you get the answer 8, and then that's what you're going to use for all 3 of these denominators. So let's change the half into an 8, something over 8. That's going to be 4 over 8. Plus, this will be 2 over 8. And of course, this stays as 1 over 8. So if that's going to be all together 7/8. There you go. Okay. All right. This one here is another one. You can pause it and copy this if you want to. Same thing here, except for you have a mixed number, an integer and a fraction. So what I would do if I were you is to just turn these all into, we know how to do these, right? Just regular fractions. So let's just turn these into fractions that look like that, right? Okay. But by the way, the next several years, a lot of the stuff is going to be, in algebra and all this, is going to be taking a new looking problem and taking one step and turning it into something that you go, oh yeah, I know how to do that. Then you go, okay, I've turned it into that. Now I'm going to go ahead and solve it. So let's do this. 1.5 turns into 3 over 2. 2 1/3 turns into 7 over 3. 3 and 1, 6. 6 times 3 is 18 plus 1, 19 over 6. Now, here we can do the same thing. I think we all recognize that 2 and 3 and 6 all go into 6. Pretend you didn't. All right? Well, we can take the prime factorization excuse me, of all these, there's a 2 of 2. 3 is just 3. That's all there is. 6, you can go like this. Excuse me. That's 2 times 3. Now, if you look at this, you go, okay, I'm going to pick the one that has the most 2's. That has 1, 2. That has none. That has 1, 2. Okay, that's just 1. All right. Okay, now let's pick the most 3's. Which one has the most 3's? Well, this has a 1, and that has 1. It's a tie, so you just multiply it by 1, 3. That'll give you 23. No, it won't. It'll give you 6. All right. Excuse me. So we just make these all 6's, right? So something over 6 plus something over 6 plus, that's already 19 over 6. And 2 times 3, that'd be 9 over 6. 3 times 2 is 6, so 7 times 2 is 14. 9 plus 14 is 23, plus 19. 23 plus 19 is 42. And divided by 6. Don't forget, I might have mentioned this once, maybe twice in the first half of the book, but all fractions are, yeah, that's right, division problems. Okay, 42 divided by 6 is 7, and there you go. That's it. Okay. All right, pause it and try practice problem A. Okay, you should have found out that the common denominator was 8, so you have 4 over 8 plus 6 over 8 plus 1 over 8. 4 plus 6 is 10, plus 1 is 11. You can leave it like this if you want to. I think probably in your book, most of the time they'll have 11 divided by 8 is 1, and then there's 3 8s left over. There you go. All right, pause it and try B. Okay, well, obviously I think 6 is the common denominator, so it's going to be 3 over 6 plus 2 over 6 plus 1 over 6, which will give us 3 plus 2 plus 1 is 6. 6 divided by 6 is 1 times 6. 6. Oh, it's 1. Okay, there we go. Pause it and try C. Okay, here's where the little extra fun comes in. So it's going to be 3 halves. This is going to be 4 thirds. This is going to be 5 fourths, right? Okay, so this will actually be a neat example of how to do this. Okay, so for 2, you take your factor tree, which you don't even need to mess with. It's just 2, right? 3, same thing, right? All right. 4 is going to be 4, which is 2 and 2. So at this point, you go, okay, which one has the most 2's? Well, that does. That has 2 of them. That's going to be 2 times 2. Which one has the most 3's? That one does. That'll be a 3. All right. 2 times 2 times 3 is 12. So you need to put a 12 for your common denominator. Okay, so something over 12, something over 12, something over 12. And that'll be, let's see, 18. That'll be 16. And this will be 20. No, 15. My bad. 15. So 18 plus 16 is 34. 34 plus 15 is 49. 49 divided by 12 is 4. And then there's 1 left over, so 4 and 1 12. There you go. All right, pause it and try D. Okay, well, obviously we have 6, right? So let's go 3 6 plus 4 6 plus 5 6 is going to give us 12 6, right? 12 divided by 6 is 2. All right, pause it and try E. Okay, 8 obviously is our common denominator. We have 4 8ths plus 6 8ths plus 7 8ths, which gives us 17 8ths. 17 divided by 8 is 2, and there is 1 left over, 1/8. All right, pause it and try the last one, F. Okay, well, we have 5 fourths plus 9 eighths plus 3 halves, and if you did your common denominator, you'd find it would be 8. So we have 10 over 8 plus 9 over 8 plus 12 over 8. 10 plus 9 is 19, plus 12 is 31 over 8. That's going to give you 3 and 7 eighths, and that is it. Okay. Well, knock out, really try to get yourself the second half of the year. This is, take a deep breath. Second half of the year, make this, you're downhill, going downhill now. All these problem sets are going to take you about the same time of time to do. There's going to be new stuff you're not as good at yet, and there's other stuff you're better at. But do those practice problems really well. Knock out the beginning of the chapter stuff each time, the warm-ups, and get those done. And that should do it for today. So, all right, have a great day, guys. See you next time. Hello there. Welcome back to Saxon 7.6. We're doing the second. H-I-J. Hey y'all, let's look at 62. Writing mixed numbers as improper fraction. A mixed number, don't forget, mixes an integer, a whole number, what we might casually call a whole number, and a fraction. So let's look at a practical problem here. There were 5 3/8 pizzas in the oven. The restaurant worker cut the whole pizzas into eighths. How many slices of pizza were there after she cut the pizzas into eighths? Boy, it reminds me of a restaurant one time when I was probably a few years ago. And the waitress comes up and says, "You want a large pizza, right?" I said, "Yeah." She says, "Do you want me to cut it in 4 pieces or 8 pieces?" And I was like, "You better make it 4 pieces. I don't think I can eat 8 pieces." Okay, here you're the pizza cutter. Cutting all those pizzas into eighths. Well, okay, well, how many eighths are in one piece of pizza? Obviously 8, right? So if you have 5 of those 8 pieces, you have 5 times 8, which is 40. Right? But you also have 3/8 of a pizza as well. So you have 48 plus 3/8, that's 43/8, right? In other words, there's going to be 43 pieces of pizza. Or if you wanted to cut it into eighths, you look at this, you go, okay, that's 43 divided by 8. Well, that is 5 pizzas, right? Right? If there are eighths and you put them all in to make a big pizza, they'll take 8 of them. There'll be 5, groups of those. There'll be 3 left over, and there you go. And that shows us a principle. You can take a mixed number like this and turn it into an improper fraction. The reason they call it improper is because the numerator is bigger than the denominator. So that's all we need to do. And the method of doing this is this. Look at this, how we got 5 3/8 and turned it into that. What we did was we took this denominator, multiplied it by the integer, and then we added that. So in other words, if you have 7 1/2, right? Let's say, what is that as a mixed number? Well, you would go 2 times 7 is 14, plus the 1 is 15. So 7 1/2, let me write that. 7 1/2 is going to be the same thing as 15 divided by 2. And by the way, every fraction is, 15 divided by 2 is 7, right? And there's 1/2 left over, right? And there you go. That just proves that it works, okay? Let's do a couple of these. Write 2 3/4 as an improper fraction. In other words, can you visualize 2 3/4 pizzas if you're a visual learner? If you're a nasal learner, can you smell 2 3/4 pizzas? Okay. Well, 2 3/4 pizzas, how many fourths would be in that? There'd be 4 in the first one, right? There'd be 4 in the second one, right? That's 8. Then there'd be 3/4, that's 3 more. There'd be 8 pieces, and then 1, 2, 3, 11 more pieces, right? And the pieces are, the fourth of the pizza. But let's just prove this, okay? 2 3/4. We're going to go 4 times 2 is 8, plus 3 is 11/4. That just proves we're right on what we just said a second ago, right? Okay. 5 2/3 as an improper fraction. Can you visualize 5 2/3 pizzas? I'm sure you can, okay? Or you can smell them if you're the nasal learner. Or you can listen to them if you're an oral learner. Listen. Listen to the pizzas. How many thirds would that be of 5 2/3 pizzas? Well, we could just go, okay, like that. Well, 3 times 5 is 15, plus 2 is 17. That's going to be 17 hunks of thirds of pizzas if you cut them really, big slices. And then that's how many there'll be in 5 2/3 pizzas. There we go. Okay. All right. Try one more. This is a multiplication problem. We're going to write 1 2/3 and 2 2/5 as improper fractions. Then multiply them. What's the product? Okay. Go ahead and pause it. Write both of those as improper fractions. Then multiply them. Pause it and go ahead and do it. Okay. You should have got 5 thirds for the first one. 3 times 1 is 1 plus 2 is 5. We're going to multiply that by 2 2/5. 5 times 2 is 10 plus 2 is 12/5. Multiply the fractions. Now again, you can either cancel, or you can just, if you did like this, 5 times 12 is 60. 3 times 5 is 15. 60 divided by 15 is 4. That's okay. You could have also done, that cancels there. And 12 divided by 3, that's 4. Well, looky there. Okay. And by the way, you should very quickly, if you have a chance, if you go, oh man, I forgot how to do this, I'm not sure what a reasonable answer is. Well, think about this. This is about how much? 2, right? If you were to round it 1 2/3. 2 2/5 is also about 2. If they're asking you to multiply about 2 and about 2, the answer is going to be about 4, right? Okay, so if you get the answer, go, I got the answer, it's 71 over 9 or whatever. You go, 71 over 9 is, let's see, it's almost 8. And, wait a minute, that can't be right. Less than 2 times a little more than 2, that can't be 8. I must have done something wrong. That's a good check for yourself. Okay, all right, let's try practice problems. Pause it and do A. Okay, A is 14/5. All right, pause it and do B. 7/2. There we go. Pause it and do C. 7/4. That's what you got? Good. Okay, pause it and do D. 25/4. Pause it and do E. All right, 11/6. Okay, pause it and try F. 33/10. Good. Pause it and try G. There we go. That was kind of fast. Sorry. Pause it and try H. 25 over 2. And pause it and try I. 19 over 6. All right, this is the doozy. J. All right, do the multiplication. Do a guess first. Look at that problem. Guess about an answer. Then when you get your answer, make sure your answer is pretty close to your estimate. Okay, pause it and try J. Okay, 1 1/2 is 3/2, right? And 3 1/3 is 10/3. Now, by the way, first, I'd say 1 1/2 and 3 1/3 be a little more than 3, maybe 4 or 5, something like that. Okay, so if you get, I got the answer, 812 over 9. Yeah, no, okay, a little too big. All right, this one, if you notice, you can cancel that out. And of course, 10 divided by 2 is 5, and that is, of course, your answer. There you go. All right, do a good job on your warm-ups, and I'll see you guys next time. Take care.